Those of you who don't know me, and I've spoken a number of times at ARC, I'm a 40-year plus cat. I'm a refinery cat. I'm a chemical engineer. Started in process computer control when it was in its infancy, and we had to program everything by ourselves, including the operating system and machine language and assembly line code, and finally get Fortran compilers. But using those small systems, which didn't have as much power as your iPhone does now, we were able to control about 100 control loops and 5 process units and do multivariable constraint control. So, the technology's come a long way, but the real business objectives and what you're trying to do with it remain the same. So with that introduction, and by the way, I've worked for owner-operators all my life, 3 of the biggest oil companies in Canada, and Imperial Oil, Shell, and Suncor. And just recently was with Northwest upgrading for 3 years, who were building the first new refinery, grassroots refinery, in just outside of Edmonton. That project is in construction now, due to start up in about the middle of 2017. It's a bitumen refinery. We'll process bitumen from the oil sands and turn it directly into saleable product, finished product, primarily diesel and diluent. Diluent's needed to thin out the bitumen so you can run it through pipelines. And we could talk about the Keystone Pipeline, but that's another subject. By the way, the Keystone Pipeline is very beneficial to the United States to keep the cokers full on the Gulf Coast. Those things are designed to run heavy crudes, whether you get them from Mexico or Venezuela or on the open water. It's not as secure, not as safe, not as reliable as getting it from Canada on a safe pipeline. What I'd like to take a bit of a step up on project execution. I've been involved with all the aspects of automation projects from the get-go. I don't think you need to hear about whether or not you need marshalling, whether or not you should go wireless, whether or not you should, what software to buy, what systems to buy, whether or not you should decentralize or centralize your control rooms. All that good stuff, you're smart people and you can figure out yourself. But what I'd like to really talk about is, let's do it right the first time so we don't have to do it over. So let's look at what is right and what are the requirements. That's a wonderful phrase from IT that uses all the time. What are your requirements? Just a new phrase for the old saw about define what you really need. And what technology paradigms we're looking at, and hopefully how to predict where the future is going with enough certainty that you can do it right the first time. Talent hits a target that no one else can hit. That's talent. But genius is being able to hit a target that nobody can see, including you. So maybe that's what the key to all this is. So why is it, and project managers and I have talked about this over a number of years, why is it that there's never enough money to do it right, but there's always enough money to do it over? And, sometimes we just have to seize control of the project and fix it and get it to the point where we can start it up safely. And safe startups and safe and sustainable operation is very key. If you've ever been involved in an incident, fire, explosion, fatality, and where an automation system's been involved or anything else, it's something you don't want to repeat, believe me. But what's right? Nobody really strives to be wrong. Everybody's trying to do the right thing at the right time. And what is right for today kind of changes because all the technologies really is changing faster and faster that you can employ and leverage and get cost savings out of. But myopic near-term design, in my experience, has always led to higher sustainment and higher life cycle costs. And that's probably even more true today because systems are coming obsolete faster than airplanes. back in World War II even. You know, an airplane was usually obsolete before it got off the drawing board, but you had to build it anyway. And if the Wright brothers had waited for the jet engine, they would have never got off the ground. So you start with the best you have, but you should design so that you can easily expand and migrate that system towards where you think the technology is going to go in the next 5 to 10 years. Stephen Covey says, begin with the end in mind. And that's a really good concept for almost everything. But where's the end? If the end simply satisfies your known requirements, then your solution at the same time is really your legacy. And these systems last for 20, 25 years. And the refinery that I was superintendent of process control, the DCS was finally changed out and upgraded. If I remember right, it was 22 years after it was installed. And of course, we were having trouble finding spare parts. And hitting that target, like I said before, is a future target is a challenge. The genius is in crafting an automation environment whose lifespan could exceed 2 decades, 20 years, 25 years, where it will continually serve up data in a technical infrastructure that will go through 4 or 5 generation changes. The IT business environment, you've seen that happen. The old DCS system that was still coughing up measured variables, it was there and doing that long before anybody ever thought of an ERP. So your automation systems really provide the basis for a lot of business information. And by the way, best definition I've ever heard of information is it's data that's used in making a decision. Think about that. You got a lot of data. Big data is nothing new. We've had big data for years. The challenge is what to do with it and how to turn that data into information. What decisions you need data for in order to make effective decisions. The automation system is a fundamental, solid basis system that provides information for the whole enterprise. People didn't realize that until recently, I think, because the ERP systems had trouble connecting to the physical world. And the CIO of Suncor came to me about 15 years ago and said, well, no, quite not much, but says, you know, we got this big ERP system we're putting in. We need to calculate KPIs. Cliff, you got a lot of that production data in your automation, your operational systems in the plants, don't you? I said, yeah, Joe, we have. He says, how do you get it into the ERP? I said, well, let me come and talk to, I know that ARC is doing some work in that regard. Let me come and talk to those guys because I know a few of them. And they were talking about plant-to-business integration at that time. So I came down and we started looking at this and discovered something called interoperability, which we'll get into a little later. But your automation system is connected to the real world. A lot of business systems aren't. So they rely on your automation system to feed them. You're also able to calculate a lot of unmeasured variables that you can't measure with the sensors. In my line, you know, vapor-liquid equilibria in a distillation tower, reaction kinetic coefficients in a reactor, etc. You can do that online, so parameters and attributes and indicators. Be able to provide the ability, of course, to manipulate the process. So you're reaching out and you're directly turning those valves. By the way, there's a safety component there too, because in our business, you turn the valves right, good things happen, you make money. You turn the valves wrong, bad things happen. Things can go bang. Things can catch on fire. People can get hurt. Equipment can get damaged. And in the worst case, people can get killed. And it's happened. And then part of that is to attach it to other software where you can access that data. Well, of course, turn it into something that you can read like engineering units and then historize it and provide the historical basis and And interesting enough, when I first talked to our first ERP vendor and they wanted all the data from the plant all the time, then I told them how much we were generating every minute. They choked. Wouldn't be so bad now. They've got better technology now. But the role of the business comes to play. So the system becomes a root source and a foundation for your entire enterprise. Measuring those KPIs, for instance, that management wants to see on what the plants did today, how much feedstock did they run, how much product did they make, and what was the quality of that product, and where is it? Your automation system and your data historian has that information. The business needs it. So the role is to serve it up. And it also, in that way, it provides direct indicators of the health of the enterprise. Management is always looking for that. Where are we making money? Where are we losing money? And how much and why? So automation systems are kind of the root system for measuring the health. Just like in the health environment, it's measuring your heart rate and your blood pressure and your temperature and the height and the weight of the enterprise. So automation systems are playing a more critical role than I think Stick Hill said yesterday than they were ever conceived to be playing in the beginning. So one of the keys to genius here is place equal weight on those two roles. And you can see on this kind of structure as things are organized today. The automation system's connected to the physical devices below a standardized service bus, and then feeding the enterprise systems above it at the top of the ERP, the bottom are the devices. And there's all kinds of applications that need that data. And so we get talking about how to exchange that data so that it can be used as information in other applications in order to make decisions. And good decisions. And then we start looking at, the business starts saying, well, we need to be more agile. And we need to be able to make those decisions faster. This classic example in a refinery, oil refinery, is we don't know how much money we made or lost, or where we made the money, or where we lost the money, for usually a month to a month and a half after it happened. Because the accounting people in their systems, they have to do a month end, and they have to get all that information in their systems, and they have to close the month end, and then it takes them 2 weeks to crunch the data and finally generate a report, which is usually exercise in creative writing and a lot of excuses about why you missed the profitability targets that you're running at in the first place. So the enterprise is headed for real-time or near real-time feedback. Who's going to provide it? Who's got the root data that can be used to provide the information needed to make the decisions? And then we can't forget at the same time that these things are connected to the physical plant. Things can go bang. So you have to make sure that you pay attention to your safety and reliability, environmental, regulatory, and all those other things that come into play at the same time. Gets to be a little daunting. Much more so than it was 25, 30, 35 years ago. And of course, the technology industry is rolling right along. So we got all kinds of new and interesting things coming up down the pipe at us. Virtual reality, 3D printing, big data. As I mentioned before, I find that a little humorous because we've always had big data. What do you do with it? We in Canada love our hockey. And when you look at prognostics, the biggest role of prognostics is to try to tell you what's going to happen in the future. Wayne Gretzky was the greatest hockey player probably had ever lived, and his dad taught him Go to where the puck's going to be. Don't go to where the puck is. Don't chase the puck. Go to where the puck's going to be. Well, he was taught how to figure out and how to know almost instantly where that puck's going to be. And that's where he went, and that's how he scored so many goals and got so many assists. But if you don't know where the puck's going to be, how are you going to get the information to make the decision? And of course, the cloud and software as a service is running along too, and you have to make decisions about all that proprietary information you got. Do you really want to expose it to the rest of the world? And of course, there's private clouds, and you have to make decisions about what to do about that. Interoperability, I'll get into a little bit at the end, but these systems now have to talk to each other. And you don't want to be tied to proprietary solutions, which box you into a corner, because then you're at the mercy of what other people decide to do. So the best thing to do is to link these together on a standardized basis, and there's a lot of work going on in that regard right now. And that brings us to the evolving standards. So how much is known and understood about these business domain technologies, and how are they being factored into your requirements? You've got to think about it, more so now than ever before. So, big data we've talked about. How does your automation system publish its data? How does it, can it respond to requests for specific data from other applications? And how do you do that without custom programming an API? How do you do that without knowing what the format is in the other system that is asking for it? And mobile technology. We've always been interested in mobile technology, but in our case, it has to be intrinsically safe. If you drop the thing and it causes a spark, it must not cause, in a hydrocarbon volatile environment, it can't cause a fire. So, and then the access. You need your operators, your maintenance people, whoever's in the plant, and even outside the plant, need to access both the automation domain and the business domain. There was an interesting discussion yesterday from a fellow at IGRIM who was using a handheld to address that problem. The Internet of Things. Interesting. I've heard a lot about the Internet of Things, but in a way, automation systems have been an Internet of Things ever since we started putting microprocessors into smart transmitters and smart control valves. This is just more of the same. People are becoming more aware of it, and it's a good thing. But then how do you go with that flow? And the cloud. We used to have all our computing and all our memory in the control room, and then we kind of moved it to the administration building, and then we started serving it up to the head office systems. And so how much do you use the cloud and leverage the cloud, and there are the applications designed to run in the cloud. And by the way, do you really want the system that is actually reaching out and moving your control valves to be in a computer somewhere, God knows where in the world? Something to think about. Persistent topic of these conferences for the last 15 years that I've been coming here has always been the collaboration between classic IT and automation IT and automation computing. And it has never been more critical than it is now. And something you have to carefully think about, because in general, the IT folks don't understand the plant. They don't understand the processing. And in my business, they don't understand what's going on inside the steel, because they're not trained as chemical engineers and the like that do understand that. So because you're reaching out and moving the valves with these systems, be careful. There's a lot of work going on the so-called ecosystem right now to manage and bring these systems together in a standardized way. And there's When you look at the business systems and big data and analytics, and you look at the life cycle across, the design of the plant, building the plant, starting the plant up, operating the plant, maintaining the plant, and after, I don't know, our refinery's been running for 55, 60 years, and it's still not in a position where we are going to shut it down, although we've shut down some different process units and built some new ones. So there's life cycle engineering that's involved. And there's a real sweet spot in that middle where they all have to meet. And that's what the standards organizations are looking at very carefully now. So when you look at the engineering that goes into these plants on the one side, and that's a database that's a lot of data about all the equipment, and compressors and transmitters and control valves and pipes and everything else that's in your plant that you need to keep up to date, because maintenance is going to change it even before you start up the plant, and the operation and maintenance environment that you're going to run the plant with. And just as an illustration, a compressor looks like that on the one side and looks like this to a process engineer on the other side. And they're looking at it from completely different points of view, and they're actually looking at different data. But both systems need to be synced in so that the data stays the same, because when you change out a part on that compressor, your maintenance system and your operating system needs to know exactly what happened, as well as your engineering system needs to know, keep a record as to what maintenance really did to it. One of the biggest problems I ever had in our refineries was had to spend millions of dollars usually to do a re-instrumentation project just to update the P&IDs, which are process instrument diagrams of process units, so I knew what was out there in the field, because over the years it had got changed. Maintenance never told engineering, because engineering couldn't change the drawings fast enough, and engineering went and built projects out there, and they never gave the information to maintenance. So it was two completely different sets of drawings and data about what was really out there in the field, and the only way we could resolve that is put a crew out there to crawl over everything and document it before we started doing the re-instrumentation project. Follow the supporting standards. There's a lot of work going on right now with the standards organizations across the life cycle. And you can see it's being pulled together under ISO. And there's a lot of technical committees, subcommittees, and technical specifications that are being written across that life cycle in order to do that. And one of the things that's going on right now, there's a lot of work being done on, is technical specification for interoperability. It will be called ISO 18101. And it's has been demonstrated and is being demonstrated in what we call the OGI pilot, which is the oil and gas interoperability demonstration. It's really industry agnostic. It doesn't have to be oil and gas. It has happened that us oil and gas guys were the guys that were really interested in pushing this thing forward. Because under this kind of system, all that every application provider needs to do is write an adapter to talk the standard language that can then transport and allow access to data from any application to any other application. It can be published, it can be subscribed. In this situation, we designed a debutanizer tower. We gave it to 3 different engineering companies with engineering software to engineer it and come up with the engineering database, Intergraph, Aviva, and Bentley. All 3 of them did it. We have it transform the standards. The University of Southern Australia actually programmed the transform engine, and there is a tag registry database in the middle of that was done by Acetricity, and that was then put out onto the ISBM, which is standard wrapper around anybody's enterprise service bus. It can be IBM's, it can be SAP's, it can be Microsoft's. That is the common language in the middle. That's the English. Those engineering systems, they can each talk different languages. One can talk Chinese, one can talk Korean, one can talk Swahili. And then we published that through the enterprise service bus and populate a data historian, build the tags for the data historian. In this case, it's OSI SOSPI. And that was done, and there's a demonstration that we did a couple years ago about that and how that is done without being touched by human hands. So your operations system now database is being built directly from the engineering database. And of course, it can go back the other way. So now you can keep your engineering and your operations and management system, maintenance systems synced without spending a huge amount of manpower and overhead. It works. There's reference data. It's all being done under the blanket of ISO now, and it's being led by Mimosa. What does interoperability look like? Well, remember that compressor? Well, this is actually a real display from the refinery, Suncor's refinery in Denver, Colorado. That's the compressor. That's how maintenance sees it. And that's all the variables around that compressor, and that's the trends of everything from process data to business data, performance data. It also, at the bottom there, has the work orders. It's got the incidents, and it's got operator comments about what is going on with that part of the process. May look similar to what you've seen on other dashboards, but it's got a difference because now you take and change a vibration probe on that compressor, and now the system says, oh, there's a new vibration probe. Is it the replacement in kind, or is it an add-on? If it is an add-on, or even if it's a replacement in kind, we can now then go back and populate the root database, and all that gets put into the databases, the appropriate databases automatically. So the data becomes associated automatically, and all the data becomes auto-generated and data aggregated without having to go into each and every database and find that and build that new vibration probe. So your components are now interoperating, and that's what we owner-operators want to see happen, because that then starts to cut a lot of cost out of the equation to maintain these systems. So by what I mean by doing it right the first time is that doing it right is greater than just your classical operations control and support and process control functions in an automation system that has to look at the current state of technology when you're designing it or migrating to a new one, and it also has to anticipate the next generation or two as to where you feel and where the best advice you have, where that technology is going to go. And it's not acceptable anymore to just stuff the data into a data historian, make it available to everybody on the enterprise and say, come and get what you want. That kind of attitude is no longer plays out because nobody's got the time. So all that biggest data sits in scads and scads of disk drives and usually doesn't get access because nobody knows what to do with it. Then there are supporting standards and strategies that then will facilitate this in the near future. And I'm chair of the Owner-Operator Leadership Council for interoperability, and any owner-operators that want to get involved with that from any industry, please talk to me. So as I said before, talent hits a target that no one else can hit, but genius hits a target that nobody, including you, can see. I have to give a little credit to my colleagues at Bruce Taylor at Suncor and Alan Johnson at Mimosa for helping with these concepts and helping put the slides together. Thank you. We'll get questions a little later, I guess. Mark?